Hello children, good evening. Welcome to today's revision class on optics. Right, so today we will focus on one small aspect of optics, but a very important aspect, that is problem solving. I'll focus on problem solving in spherical mirrors, right? Because I think that's a very important topic for your CBSE. Some of you might be facing some trouble in trying to solve problems. So we will discuss only that in today's class. I will start off with a formula, tell you what sign conventions to use, etc., and how to apply it in problem solving. We will try a few problems in today's class. By the end of the session, I want you to be crystal clear with problem solving in spherical mirrors. All right. Okay. So what is the idea? The basic idea is this. So the basic idea is the following. You know that supposing if you have a spherical mirror, as an example, I'm only taking like a concave mirror, right? So if you take a concave mirror, and let us say you kept an object here. Okay. Now, what is it you're learning in the what is it you're learning in optics? So if you keep your object here, somewhere image is formed. So you want to figure out where the image is formed for a given object, where the image is formed, right? So that is the whole purpose. So for a given object, where is the image? See, in order to do this, an easy idea would be to say, okay, when you want to say where is the image somewhere, what will you do? So you can say, okay, the image is here, the image is there, etc. But if you want to be more quantitative, if you want to be really precise, what will you do? Supposing if I ask you, where is the point? Right? Suppose if I ask you, tell me where is this point? Now, one thing is to say, okay, this point is towards the right of the screen, right? Or this point is exactly half the height from the top towards the right of the screen. You can keep telling like this. Otherwise, if you want to quantify it properly, you can simply put a coordinate system and you can say, okay, I have a coordinate system, the 0, 0, the origin of the coordinate system is here. I will tell you the coordinates of this point. Let's assume 1, as an example, right? Now, once I tell you 1, 2, the address of this point is very clearly known. You know this from coordinate geometry in mathematics, because 1, 2 would mean 1 unit this way and 2 unit this way. So you have reached this point. So the moment you specify the coordinates, the address of this point is known. So similarly in optics also, you can think of this as x coordinate of the object and y coordinate of the object, this point. And you can assume this as x coordinate of the image and y coordinate of the image. Right? So what is it you would want to figure out? For a given xo, yo, what is xi, y? An object position is given, what is the corresponding image position? So typically you would know where you are placing an object. So in general, you will know xo, you will also know y. You will simply be asked to figure out xi and yi, right? But in general, you might not have been used to this notations xo, yo. I'm also not going to use it. I'm just going to introduce it, but I'll stick to your textbook convention. So in general, supposing if you have a situation like this, okay, let us say a 5 centimeter tall object is placed at a distance of 20 centimeters from the pole. So this is how you'll be given in problems. Now the tip, if you want to write the coordinates of the tip, what can you say? You need an origin before you start writing the coordinates. So fix an origin at the pole. Right? If you fix an origin here at the pole, what will be your sign convention? Anything towards the right is positive. Anything towards the left is negative. Anything upwards is positive. Anything downwards is negative. This will be your simple Cartesian sign convention. Right? So according to this, what will be your x coordinate and y coordinate of the object? This will be minus 20. Why minus 20? If you notice this carefully, it is towards the left. So this is minus 20 and 5 is upward. So minus 20, 5. So I can say, supposing if I had my origin here, this point will have coordinates of minus 20, 5. Now, all that you will need to figure out is what is the image coordinate corresponding to this object coordinate. Right? What is the image coordinate corresponding to this object coordinate? Right? For that, we have a formula 1 by xi plus 1 by xo is equal to 1 by xf. Okay, bear with me for a moment. There is a reason why I'm introducing it this way so that you won't make mistakes. And finally, I will convert it to your textbook style formula. Okay. So what you have 1 by xi plus 1 by xo is equal to 1 by xf. So all of this xi, xo, xf, they are all coordinates. X coordinate of the object, x coordinate of the image. This is x coordinate of the focus. Focus is also a point that also has x coordinate and y coordinate. So this is x coordinate of the image, x coordinate of the object, x coordinate of focus. So remember, xi, xo, xf, they are all coordinates. The moment I say these are all coordinates, you are going to take them along with appropriate plus minus sign. Because you know that coordinates, the moment I talk about coordinates in coordinate geometry, you will typically take it with plus minus sign, right? So supposing if I have a point here, you will say, okay, minus 1 comma minus 2 as an example. This is not minus 1 comma minus 2, minus 1 comma plus 2. Right? So you will say that along with plus minus sign. So coordinates to be taken along with plus minus sign. Now, what does our textbook tell us? Our textbook tells us that 1 by v plus 1 by u is equal to 1 by f. This is the standard textbook formula that you might have seen. Now, you have v, in the place of v, I have xi. In the place of u, I have xo. In the place of f, I have xf. So, in the formula, 1 by v plus 1 by u is equal to 1 by f. Treat v, u, f as image coordinate, object coordinate, object coordinate, and focus coordinate. The moment you think of all of them as coordinates, you will never make a mistake in sign convention. You will take them along with appropriate plus minus sign. Right? So the moment you think of them as coordinates, you will never make a mistake. You will take them with appropriate plus minus sign. Similarly, magnification has a formula minus v by u. Minus v by u. Magnification has a formula minus v by u. Once again, what is v and what is u? V is coordinate, x coordinate of the image. U is x coordinate of the object. So magnification is minus v by u. So remember these two forms. Okay, I'll give you a small example. Typically, when you're given a problem like this, supposing you have a problem like this. Okay, let us say this is a concave mirror and the focal length is 10 centimeter. I'm just giving an example. Okay, let us say this distance is 30 centimeter and this is 2 centimeter. Right? And the focal length is 10 centimeter. So typically you'll be given a problem like this. They would give this problem to you in words. An object is placed in front of a concave mirror at a distance of 30 centimeter from it. The height of the object is 2 centimeter. Assuming that the focal length of the mirror is 10 centimeter, find the image position. They will give this question to you in words. But when you simplify it in a diagram, this is what you end up getting. Now, what do you see? Look at this one. You know that when you complete the sphere, right? When you complete the sphere of which this was a part of, the center will be somewhere here, the focus will be here. Focal length is given. That means this distance is 10. But I told you in the formula, 1 by v plus 1 by u is equal to 1 by f. When you're even writing it in the boards, think of them as coordinates. Don't write them as coordinates, think of them as coordinates. So what is v? Image coordinate, x coordinate of the image. So leave it like that. What is u? U is actually object coordinate. What coordinate? X coordinate. X coordinate of the object. Now, what is the x coordinate? The distance is 30, but if you write it as coordinates, the coordinates are minus 30, comma 2. If you want, you can write this in pencil, erase it later. Right? So, minus 30, comma 2. Forget about anything else. You need not remember anything else at all. This is the origin. Put your origin. 0, comma 0 at the pole. So write it as in the coordinate form, minus 30, comma 2 is the coordinate of this point. So what will be u? U is object coordinate. So take minus 30. This is the coordinate. I'm taking the coordinate as such. This is 1 by f. Right? Now f also I told you take it as coordinate. So coordinate is minus 10, comma 0. So take it as minus 10. Go ahead and solve. You will get the right answer. Right? I'm not asking you to remember anything. Sign convention, you are using simple Cartesian sign convention. Towards the right is positive, towards the left is negative, upwards positive, downwards negative. But before you start the problem, at least in pencil, write down everything as coordinates. Once you write down everything as coordinates, look at it and substitute the coordinates. You will never make a mistake in any numerical. Okay, you will never make a mistake in any numerical. Now, supposing you want to figure out the magnification, you know that magnification is minus V by 4. Now, V from here you will calculate. You can plug in that value here. U from here you already know minus 30. You can plug it in here. But remember, U, V, F, they are all coordinates. The moment you think of them as coordinates, you will never make a mistake in sign convention. So, step 1, draw a diagram. So, step 1, draw a diagram. Step 2, mark the coordinates. Step 3, substitute. Step 4 is crucial, especially in boards, check. Especially in boards, check. Okay, 4 steps for solving optics problem. That's all. Draw a diagram, mark the coordinates, substitute the value. Remember that you are substituting coordinates here in all of these equations. Calculate and then check. Now I'll elaborate what do I mean by check, then we will jump into problem solving. Now supposing, let us say you have a concave mirror. Okay. Now let us say this is the center of curvature of the concave mirror. And let us assume that this is about 40 centimeters. Now when an object is kept here, you know that image will also be formed here. Right? Image will also be formed here. Like that, you know, for different object position, where is the image position? So once you solve, check if it makes sense. For example, supposing if the object was at the center of curvature, right? But you calculate something and finally your image is not in the center of curvature. That means you have made a mistake in the calculation. So based on the properties of image formation, how would you check based on the properties of image formation? Properties of image formation. So check your final answer based on the properties of image formation to ensure that you've got it right. Okay. I'm assuming that this approach is clear. Let us quickly try solving some problems so that you're confident. Okay, I'll give you some questions. Try and solve it. By the way, today's class is going to be reasonably basic. We are going to focus only for CBSE, specifically for boards. Right? Try this question. Try question number 1. I'll give you 3 to 4 minutes. Try it. Children, I want all of you to try and submit your answer. Okay, do not worry about the answer. Whatever you get as the answer, submit it. Okay, I'll give you 1 more minute. All right, let's try this one. So how would you solve? Let's look at this. A 10 centimeter long pencil is placed 5 centimeter in front of a concave mirror having radius of curvature 40 centimeter. Okay, let me move on to the next page. Sorry. Yeah, so here we go. So this is the question. So let me first step. What is my first step? Draw the diagram. So let me draw the diagram. There is a concave mirror having radius of curvature 40 centimeter. So supposing if I were to draw the sphere of which this concave mirror was a part of, the radius of curvature is 40 centimeter, which means focal length is 20 centimeter. So the focus coordinate is minus 20, 0. I've marked it. Okay. And it's a 10 centimeter long pencil. It is placed 5 centimeter in front of a concave mirror. So somewhere here it is placed. Somewhere here. So the coordinates are going to be minus 5 centimeter, comma 10. Minus 5 centimeter, comma 10 centimeter. Okay. Now determine the position. So what will you do? So 1 by V plus 1 by U is equal to 1 by F. Now 1 by V plus 1 by U. Remember, this is U is actually object coordinate. What is the object coordinate? Minus 5. 1 by F. F is focus coordinate, which is minus 20. So let's simplify. 1 by V is equal to minus 1 by 20. When this goes this side, plus 1 by 5 into 4 into 4. So how much is this one? This is minus 1 plus 4 by 20. Right? So this is 3 by 20. 1 by, which implies V is basically 20 by 20 by 3 is approximately 6.67. Plus 6.67. Notice that I get plus 6.67. That means the object is formed towards the right side, right? Because this is your origin. So plus 6.67, somewhere here the object is going to be formed. Right? Let's make a note of this. What is the size of the image? How will you calculate? Calculate magnification. Magnification is minus V by U, minus of V. What is V? V is actually 20 by 3, right? Divided by U. U is minus 5. Minus minus sort of gets cancelled. So you end up getting 20 by 3 divided by 5. So into 1 by 5. This is 4 by 4 by. So magnification is plus 4 by 3. Okay. So determine the position we have done, size we have done. Don't stop your calculation here. Check. Now you see that clearly if this is the focus, the object is placed between the pole and the focus. For a concave mirror, if the object is placed between the pole and the focus, you know that the image will be formed behind the mirror. You end up getting plus 6.67. So definitely it's behind the mirror. Okay. And you know that if a image is formed behind the mirror for a concave mirror, that is going to be, you know that that's a virtual image, first of all. That's going to be erect and that's going to be enlarged. Erect means magnification has to be positive. It is indeed positive. Enlarged means magnification has to be more than 1. 4 by 3 is definitely more than 1. So you have quickly checked the problem. Okay, you have quickly check the problem. Sometimes what happens is when children check, they do not check it like this. They check, okay, 1 by V plus 1 by U is 1 by F. Have I substituted everything correctly? The chances are you might miss it for the second time also. Right? But check it using an alternate method. So whenever you check it using an alternate method. Here you have substituted everything using the formula. Now check it using image formation. Right? As simple as. Is the idea clear to everyone? Very good, Siddharth. Can you quickly confirm if this question is clear? Shall I move on to the next question? I'll give you a minute. Quickly let me know. If it's not clear also, you can let me know it's not clear. By the way, in your CBSE board, when you're writing it, you need not write it as, this as -5. You need not write it everything in coordinate form. You can say U is equal to -5 centimeter. F is equal to -20 centimeter. So these things, these things in terms of coordinates, you can write it down for your reference. You can write it in pencil. Okay. And you can erase it later. Very good, Siddharth. Shall I move on to the next question, children? Okay. Try this question. Come on. I'll give you 3 minutes for this question. Try it out. Come on, guys, try and submit your answer. Vishwanath, Sujay, Siddharth, Sinchana, Varshini, Sandhya. Right? I want all of you to put pen on paper. Try and submit your answer. Okay. I'll give you a minute and a half more. Try it. All right, let's try this question. So what do we do? First, draw the diagram. So this is a convex mirror, right? So you have a convex mirror. Okay. Right. Smriti is looking at herself in a convex mirror in a science museum, standing 2 centimeter away from the mirror. Let's say this is, she's standing 2 meter away from the mirror. So this is 2 meter. Her image appears to be around half her actual height, right? So you know that it's a virtual image, right? Because she's looking at her image, right? So this image is behind the mirror, it's virtual, the image is half her height. Okay. Estimate the focal length of the mirror. Now, how do we solve the problem? Whatever you know, first write it in terms of coordinates. So this is -2. You only know this y coordinate, I do not know. By the way, all of this we are going to write it in pencil. This is what you're going to write it in pencil board. Right? Right? 1 by v plus 1 by u is equal to 1 by f. And you also know that magnification is minus v by u. You know that magnification is 1 by 2. Right? Magnification is 1 by 2 because her image appears to be around half her actual height. And you know that in the case of a convex mirror, from the image properties, you know that you're going to have, for this particular case, you're basically going to have a virtual image and it's going to be diminished. But it's going to be erect. So magnification is plus 1 by 2. That is minus v divided by u. U is what? Object coordinate. That is -2. Right? So what do I end up getting? -2 by 2 is minus v. Implies v is equal to plus 1. So that means this image will be formed at a distance of 1 meter. So this coordinate will be 1 meter, comma. Okay, but you need to figure out what is the focal length. So what would you do? 1 by v plus 1 by u is equal to 1 by f. Remember that v, u, f are all coordinates. V is image coordinate, u is object coordinate, f is focus coordinate. So 1 by plus 1 plus 1 by u, u is -2. That must be equal to 1 by f. Now what do we end up getting? 1 minus 1 by 2 is equal to 1 by f. Focal length is basically, or 1 by f is basically 1 by 2, which implies f is equal to plus 2 meters. F is equal to plus 2 meters. Right? So the focal length is plus 2. And plus also makes a lot of sense because if you were to complete this spherical sphere of which this mirror was actually a part of, you know that center of curvature will be somewhere here, focus will be here. So focus coordinate invariably has to be positive, and that's what we end up getting. So I hope this question is also clear. Right? So that focus is 2, not 1 by 2. Look at this one. This is 2. 1 by f is 1 by 2. Right? F is 2. This is also one of the common mistakes because whether you calculate v, f, etc., all of it is going to be reciprocal because in the formula it is 1 by v, 1 by f, and so on. So this is 1 by f is 1 minus 1 by 2, which is 1 by 2. F is 2. So this step, do not make a calculation. This is clear, Siddharth, but very good try, Siddharth. Sinchana, Varshini, is this clear to all of you? Vishwanath, Sujay, Sandhya. Shall we move on to the next question? I'm assuming that this is clear. Let's move on. Try this question. I'll give you 3 minutes for this particular question. Try this. Siddharth, no problem. I understand by mistake you've taken the reciprocal, but do not make the mistake in the exam. So these are all areas where you need to check. See, right now when you're solving a problem, you know where you're making a mistake, right? So when you write your board exam, so whenever you're checking, check whether you have taken all the reciprocals properly. So you know where you'll be making a mistake. So check those areas carefully. All right. Okay. Try this question. Come on. All right, let's try this question. Siddharth has tried very good. So let's try this out. What do we get? Size of an image of an object by a mirror having focal length 20 is observed to be reduced to 1/3 of its size. Right? So magnification is 1 by 3. At what distance the object has been placed from the mirror? What is the nature of the image and the mirror? What is the nature of the image and the mirror? Okay, let's think about this one. Now, magnification is 1 by 3. From here, let's try and figure out. So, you have magnification is minus v by u, that is equal to 1 by 3. Okay. Similarly, 1 by v plus 1 by u equals 1 by f. 1 by v plus 1 by u equals 1 by f. You clearly know that this is 1/3, right? So you know that this has to be a virtual image and it has to be behind the mirror. It is diminished. So this is going to be a convex mirror, right? It's going to be a convex mirror. So use this idea, go ahead and solve the problem. So what do we end up getting? 1 by v plus 1 by u, right? U is what you need to actually figure it out. It's basically 1 by f. So focal length is positive. Why positive? Because for a concave mirror, this is how you would draw. This is the origin, 0, 0. This is the focal length. Somewhere focal length will be here, that's positive. So this is 1 by plus 20. Now you need to figure out at what distance the object has been placed from the mirror. So you need to figure out u. Right? So from here I can say minus p is equal to u by 3. Right? So p is equal to minus u by 3. Let me plug it in here. 1 by minus u by 3 plus 1 by u is equal to 1 by 20. So you can say minus 3 by u plus 1 by u, that must be 1 by 20. Minus 3 plus 1, minus 2 by u, that must be equal to 1 by 20. U must be equal to minus 1. That means the object is placed 40 centimeter in front. The object is placed 40 centimeter in front of the right? By sign convention, this is going to be the coordinates are going to be 40, 6. Right? So what is the answer? The at what distance the object has been placed in front of the mirror? 40 centimeter in front of the mirror. Okay. What is the nature of the image? Nature of the image is virtual, erect, diminished. What is the mirror? The mirror is a convex mirror. The mirror is basically a convex mirror. Okay, so I hope this idea is clear. Very good. Sandhya, is this now clear to you? Sandhya Kasturi? Take a moment, think and let me know if this is clear. I'll give you a moment, think and let me know if this is clear, then we'll move on to the next list. Siddharth, very good. How about Varshini, Sinchana, Vishwanath, Sujay, is this clear? Sandhya, work it out once and let me know if it's clear, okay? I'll give you a minute, go through this, then we'll move on. Okay. Now, before we move on to the next question, see if some other case is also possible for this question. Right? See if some other case is also possible for this question. See, because this question, we are figuring out what the mirror is. Right? So I assume that, okay, let it be a convex mirror. But is it possible for us to have a concave mirror in this case? Think about it. What is the condition? Focal length is given and magnification is given. Magnification is 1/3. Right? It could be plus 1/3, it could be minus 1/3, that I don't know. So the size is 1/3. Right? That means if something was 6 centimeter object, image would be 2 centimeter. That's the idea. Right? If image is 6 centimeter, object is 6 centimeter, this would be 2 centimeter. But from this, you can't directly conclude whether magnification is plus 1/3 or minus 1/3. That you can't conclude. Think about it. The condition is focal length is given, size is given. Magnification is also not given. At least at the given magnification is equal to plus 1/3, you can for sure conclude that this is a convex mirror. But magnification is not given. Size is reduced to 1/3. So, in fact, this problem turns out to be interesting because you have one more case. So, this answer is assuming. So, this is assuming the mirror is convex. But who said the mirror must be convex? It could have been concave as well. Let's try, because for concave also this is possible. Supposing you had a concave. Focal length was given to be 20. So focus coordinate is minus 20, comma 6. Right? And object, the image size is 1/3 the object size. But you know that when you talk about concave mirror, you cannot have a virtual image which is diminished. Think about the image properties. From the image properties, you know that concave mirror, it forms a virtual image when you place the object between the pole and the focus. So this is slightly involved. So think about it. Right? When you place the object between the pole and the focus, you know that a concave mirror forms a virtual image. That virtual image is going to be formed behind the mirror. It is going to be erect. It is going to be enlarged. It is going to be magnified, But there are cases where concave mirror can form diminished images. When can they form? Right? It can form diminished images, but that, if at all it's forming a diminished image, that has to be a real image and the image has to be inverted. And the image has to be inverted. You know that. Now let me quickly draw this. Different cases for image formation. Let us say this is focus, this is center of curvature, this is beyond center of curvature. Supposing if you are at infinity, image is formed at the focus. Right? If you are beyond center of curvature, image is formed here. Center of curvature, if you are at center of curvature, image is formed here. Same size as that of the object, but like this. Now, if you are between center of curvature and focus, image is formed beyond the center of curvature. So you see that as you keep going from infinity towards the focus, right? As you keep going from infinity towards the focus, what happens? Initially, if the object was at infinity, image was at the focus. If the object is beyond C, image is between C and F. If the object is at C, image is also at C. If the object is between C and F, the image is beyond C. So this is what happens. Now C, same size. But this case, if the image is formed between center of curvature and focus, the image can turn out to be diminished. Right? But it is inverted. So if at all we are thinking about this case, I can take magnification is equal to minus 1/3. Why minus 1/3? Because the image is inverted. So let's go ahead and solve the problem. Minus 1/3 is minus v by u, which implies v is basically equal to u by 3. Now when you use the formula 1 by v plus 1 by u is equal to 1 by f, everything is all coordinates. So 1 by v, I'm writing it as u by 3 plus 1 by u, that must be equal to 1 by f, this is minus 20. So you've got 3 by u plus 1 by u, that must be equal to minus 1 by 20. 4 by u must be equal to minus 1 by 20. Right? 4 by u must be minus 1 by 20. So 1 by u is minus 1 by 80. U is minus 8. U is minus 8. So this is also possible. Right? If at all it's a concave mirror, the object is placed 80 centimeter in front. Right? 80 centimeter in front. And what is the nature of the image? The nature of the image is basically going to be real, inverted, diminished. So even this case is also possible. So actually there are two possible cases, right? This is case 2, assuming the mirror to be concave. This is also possible. Supposing if the mirror is a concave mirror, the object must be placed 80 centimeter in front. Supposing it's a convex mirror, it must be placed 40 centimeter in front. And you see the different image. I'll pause this here. Sandhya, when the image is smaller, the magnification is not negative. Magnification, whether it is positive or negative, that is dependent on whether the image is erect or inverted. Now look at this. In this case, you see that if at all it's a concave mirror, if it has to form a diminished image, there is no option. The image has to be inverted. Because the image is inverted, I get magnification minus. Okay. But earlier, look at this. There's one more problem where we did magnification, right? Look at this. Magnification is 4/3. It indicates that the image is basically erect, right? So let me also write the conclusion so that it's easier for all of you to follow. Now, depending on magnification, from that information, what all can you figure out? If magnitude of magnification is less than 1, forget about the sign because it has both a sign and a number associated with it. If the magnitude of magnification is less than 1, that means it is diminished. If magnitude of magnification is more than 1, that means this is enlarged. If magnification is positive, that means the image is erect. If magnification is negative, that means it is inverted. So this plus minus tells you whether the image is inverted or erect. Whether the magnitude is more than 1 or less than 1 tells you whether this is enlarged or diminished. Okay, it's useful to remember these ideas. Correct. Siddharth, U is equal to minus 80 centimeter in case of a concave mirror. Absolutely right. Absolutely right. Okay. So there are two answers possible depending on what mirror we are thinking about. Sandhya Kasturi, is this clear now? Very good, Siddharth. You have given an answer for both the cases. Excellent. Now, why there is two cases? Because looking at this, you can never figure out what kind of mirror it is, right? Because a concave mirror can have certain focal length, image can be 1/3. For a convex mirror also it's possible. The only difference is for a concave mirror, it is going to be diminished when the image is virtual, right? Sorry, for a concave mirror, it's going to be diminished when the image is real. For the convex mirror, it is going to be diminished when the image is virtual. That's the only difference. Think about it, absorb it, take your time and let me know if this is clear. We'll move on. Sandhya got it? Okay. Any other doubts in problem solving? Shall we try one last question? I would want you to try one last question for today. Okay, try this. 2 more minutes. All right. Now, what is this question about? See, here also in this question, very good, Kasturi. So here also in this question, they have not told you whether it's a concave mirror or convex mirror. But here, you need not assume two cases. You need not say, okay, first I'll assume concave, then convex, not necessary. Because the hint is here. Look at this. A student wants to project the image, wants to project the image. That means there must be a real image formed. Then only you can project it. But you know that a convex mirror never forms a real image. So it's a concave mirror. Okay. So therefore, whenever even you want to solve problems, let's say in spherical mirrors, the image formation, its properties have to be clear. Because otherwise here you're going to think whether it's concave or convex. If you take two cases and solve it, it not make any sense, right? Because if you want to project an image, the image has to be real. And a convex mirror is not going to produce a real image. So the image is going to be formed with the help of a concave mirror. Right? So the first part is concave. You can present your argument. Okay, concave mirror. Calculate magnification, distance between the object and the image. Draw a ray diagram to show the image formation. Now first, 1 by v plus 1 by u is equal to 1 by f. Right? Now it's a concave mirror. Screen is at a distance of 60 centimeter in front. So v is minus 60. Right? So the image has to be captured on the screen. So if the screen is 60 centimeter in front, the image position is minus 60. Okay, by keeping a candle at a distance of 15 centimeter from the pole. So u is equal to minus 15. Plug both of them and see what is the value of f. In fact, if our assumption that this is concave is correct, right, you will also see that this focal length will turn out to be negative. Let's also confirm. So what is this? 1 by v plus 1 by u. That must be 1 by f. Of course, the answer will turn out to be negative. Right? But you need not calculate for f. All that you need to do is calculate the magnification. What is magnification? Magnification is minus v by u. Right? Magnification is minus v by u. How much is it? Minus v by u. V itself is minus 60. U itself is minus 15. So you end up getting 4 times. Right? Magnification is minus 4. Now, magnitude wise, this is more than 1. So that means the image has to be enlarged. And sign wise this is negative, so this means it is inverted. Inverted and enlarged. Inverted and enlarged. So magnification produced. Magnification is -4. Distance between the object and the image, clearly 45 centimeter. Right? Because image is at -15, object is at -60. Sorry, image is at -60, object, this is image. Image is at -60, object is at -15. Distance between them, clearly 45. Draw a ray diagram to show the image formation. Now here, once again, you need to think a bit. You need to think a bit. Right? Now the image is enlarged. But when do you get an enlarged image? If at all, you keep the object. Right? If at all, you keep the object between center of curvature and the focus, you end up getting an enlarged image. So you must draw your diagram like this. Right? So what you end up getting? One ray goes and hits. Right? Passes through the focus. The other ray you can draw it like this. Goes this way. Right? So let me draw the diagram properly. Hold on for a second. This is center of curvature. Let's assume that this is the focus. Let's say you have an object here. Now one ray parallel to the principal axis after reflection passes through the focus. One more ray goes like this. After reflection goes this. So this would be a proper ray diagram. This would be a proper ray diagram. Okay. This would be a proper ray. Right? Now from the ray diagram, you know that this has to be between C and F. Right? So let us just do a quick check. Right? Let me calculate for focal length first, and then let me check whether the object is basically placed in between center of curvature and focus. Let's check that. So how much is this one? Into 4 into 4 if I do, this must be 1 plus 4 divided by -60. That must be 1 by F. 5 by -60 must be 1 by F. So F must be -12. 12 5s are 60. Right? So this is -12. Okay, but where is the object placed? -15. -15 is somewhere here. So everything is all consistent. I'm using this to check. Absorb this idea slowly and let me know if you have understood this. Very good, Siddharth, Kasturi. Excellent. Very nice. See, checking part till here, that's clear. But how do you check? Once again, don't check the numbers. Anyway, if possible, check the numbers. But if you check it using some other methods, typically what happens is, if you keep checking your numbers, if you keep running through the numbers multiple times, if at all first time you have made a careless mistake, the chances that you will spot it the next time is also quite rare. But if you verify your answer with another method, for example, right now I know that magnification is -4. So that means image has to be inverted and enlarged. For that, from the image properties, I know that the object must be placed between C and F. All of this I know qualitatively. Now quantitatively, if I calculate the focus and if I look at where is the object placed, if those two match, that means chances are that my answer is actually right. So you can also use an alternative method to check. Okay. So I'm assuming that this part is also clear. Most of you have given right answers. Very good. So once again, remember key ideas. U, V, F are all, treat them like coordinates. You need not write it explicitly in the paper that they are coordinates, but think of them as coordinates so that you don't mess up with plus minus sign. And I'm using a simple Cartesian sign convention. But if at all you write coordinates in the CBSE board paper, erase it. Right? Write it in pencil and erase it, because when they evaluate multiple papers, it will be better if all the papers are looking similar. But the moment you write it as coordinates, the chances that you make a mistake is going to be relatively negligible. Right? So I hope this idea is clear, and I'm sure that most of you might find it a little easier to think about problem solving in spherical mirrors now. Right? Wishing you guys all the very best. Looking forward to meeting you all in yet another interesting session sometime soon. Till then, take care. Bye.